I'm now going to solve some absolute value equations, and let's start with a very simplest type. Let's solve something like this. Absolute value of x equals to 2. Okay? And so we could verify by inspection that the absolute value of 2 equals to 2 and the absolute value of negative 2 equals to 2. And so this has two answers. X equals to 2 and negative 2. Well, you could memorize that, I suppose, as a pattern, but let me tell you that when we get to the inequalities, you're much better off understanding absolute value than trying to memorize some patterns, because it's really easy to get that stuff all backwards when you attempt to memorize. So I would say make the effort to learn absolute value as distance. And what does this describe? This describes, and I'm going to write it this way, the absolute value of x would be the same as absolute value of x minus 0. This describes all the numbers x which are a distance of 2 from 0. So on the number line, it's quite visual. What numbers are a distance of 2 from 0? And that would be negative 2 and positive 2. End of story. All right, now let's make it just a little more complicated. And we'll solve a linear inequality, a simple linear inequality. So how about we have the absolute value of 2x minus 5 equals to, I don't know, 7? Like so. Okay, now how do we interpret this? Well, remember that absolute value is a subtraction, and through the subtraction you understand what the distance is between. There's a distance of 7 between 2x and 5 on the number line. All right, so let's look at that. Here is 5, and if I go forward 7 units and backwards 7 units, so let me draw that in. Then this means that 2x is either here or there. Alright, so again, and by the way, this is not normally the way I describe this. I think I have probably a simpler way of describing this in a minute, but I want to be consistent with the definition initially here. So this says that this is a collection of points, x, such that the distance between 2x and 5 is 7. Here's 5, 7 forward, 7 backwards, gives me negative 2 here and 12 over there. And 2x is equal to that, because that's the distance. So we have 2x equals to negative 2, and 2x equals to 12. And then solve, divide by 2, x would be negative 1 and also positive 6. So you can plug those numbers in there, and it would be pretty easy to verify that this is going to work. All right, now to me this is a little more complicated than I would prefer. I think there's probably a little simpler way of looking at this. So I wanted to first show you something that was consistent with the definition I gave you in the last video for absolute value. But now let's adapt that and think of this a little differently. So this might be a little less complicated way of working this problem. So here's how I want to think about this problem, and hopefully this will be maybe a little more straightforward to you. This 2x minus 5 represents some points that are a distance of 7 from 0. And so on the number line, here is 0. 7 and negative 7 are a distance of 7 from 0. And so this 2x minus 5 must appear here or there. And so this quantity itself is a distance of 7 from 0. And it's to be consistent with how I was defining absolute value earlier. You could think of it this way. The the distance between this quantity and 0 equals to 7. But normally you wouldn't write all that stuff out. I just wanted to justify how I was showing this. Alright, if that's the case, then this sets up two equations again. This says that this quantity inside, 2x minus 5, is equal to negative 7, and 2x minus 5 is also equal to positive 7. So that sets up two equations to solve. And then we'll finish here. I add 5 to both sides. Negative 7 plus 5 is negative 2. Divided by 2, x is negative 1. Add 5 here to both sides. 2x equals to 12. X equals to 6. So I would prefer you bring that together into one solution. And I want to write it so that negative doesn't get lost in the shuffle too badly. There we go. X is negative 1 and positive 6. So that's an alternate way of thinking about this. And I think you'll find this ultimately to be probably a little faster, a little quicker to think through accurately. Well, let me show you a mistake some people will make with absolute value. And it goes back to the idea that absolute value, all it does is just change negatives to positives. No, it doesn't. It can. But the absolute value, need to make some room. The absolute value of 2x minus 5 does not change negatives to positives. In other words, it's not the same as absolute value of 2x plus 5. It's absolutely wrong. Now, the reason is because that is selective changing of the signs. We say, well, it's okay to change one part of this, but not both parts. And so that would render it wrong. And the answers you get, negative 1 and 6 for this problem, are easy to confirm. However, they will not fit here. If you put those answers into 2x plus 5, you will not get 7 after you take the absolute value. Now, it would be okay to say that this is equal to the absolute value of negative 2x plus 5. And you see why. It's as if I factored out a negative sign from 2x minus 5, changed the signs, and brought it outside, but the absolute value of a negative 1 is 1. And so it's easy to confirm that these are true. So it would be permissible mathematically to change all the signs inside an absolute value. It's rarely desirable or even necessary to think about doing that. I just want to point out that it would be okay to change all the signs inside an absolute value, but not under no circumstance can you just change some of the signs, but not all of them. All right, let's do one more, and I'll erase the board. Actually, I want to do two more, and this one will go very fast. Absolute value of 4 minus 2x plus 3 equals to 0. What's the answer? See it? There is no answer. Why? Because absolute value has to be positive. Positive plus 3 cannot be 0. And so it would be the same thing as writing this by bringing the 3 to the other side. 4 minus 2x equals to negative 3. Absolute value can never equal to negative 3. So in either case, there would be no solution to that problem, because the absolute value cannot be a negative number. Distance cannot be negative. All right, now let's turn this into a problem we can work. So I'm going to new problem, and all I'm going to do is change the plus to a minus. So let's go with that. Now we can solve it, because I want to isolate the absolute value from the constant 3. So I'm going to add 3 to both sides. This gives me absolute value 4 minus 2x equals to 3. And I'm going to take this approach again, saying that this represents quantities that are a distance of 3 from 0. In other words, the 4 minus 2x is both negative 3 and positive 3. Sets up two equations. So I have 4 minus 2x is negative 3. 4 minus 2x is positive 3. And now we'll just finish. I'll subtract 4 from both sides here. Negative 2x is negative 7. Divide by negative 2. The negatives cancel. So I get 7 halves. Here, subtract 4 from both sides. And I get negative 2x equals to negative 1. Divide by negative 2. And again, the negatives will cancel there. So I get two answers, which I would normally write below, but I'm out of board space, so I'm just going to fit them in over here. I would prefer if this you were writing on paper that you would write below. But my paper's not too big in this video. Alright, so x is equal to 7 halves. It's also equal to 1 half. There we go. So there's our two answers. And it wouldn't be a bad idea to check them. You could plug those numbers in. It actually would check pretty easily because when you multiply by 2, the fractions will disappear. So it would be fairly easy to check that answer. All right, well, it is typical in an absolute value problem to get two answers. The one instance where you would get one answer would be if the absolute value is equal to 0. I think that would be true. And, oh yes, because the distance from 0 to a quantity equals to 0 puts you right on the 0 mark. So that's the only time you would get one answer in these that I can imagine. And, okay, well now we're going to take this knowledge and go on to the inequalities, which is really the main event here in this section.